Hey guys, today we're going to take a look at a really important topic that shows up on the AP exam a lot. We just got done talking about Riemann sums and how we can use this long Riemann sum to show what really the definition of a definite integral is, or how we can do it the long way. Now, although you may not have to do a long Riemann sum on the AP exam, you will be given questions that look like this, which is a Riemann sum. There is a trick to these though. Rather than evaluating a whole Riemann sum, we can turn these into definite integrals. And so if we can turn it into a definite integral, we can evaluate it like we've been doing in class the last couple of days, which is much easier than doing a long Riemann sum, which everyone would probably agree. So the trick to this is actually getting some colors and doing some circling and turning things and figuring out which part represents which part of a definite integral. So if you have some color pencils or color pens, this is a good time to get it out and work along with me. All right, we're going to take a look at this worksheet that I have here, but I'm going to jump around a little bit. This is actually question number 4. Some of the questions are a little bit easier to explain, so I'm going to jump back and forth between numbers, and that way you can do the rest of it on your own. Number 4 is probably one of the easier ones to look at. First thing we're going to do is take your first color, whatever that color may be, and I'm going to circle the limit and the summation. That tells me I'm dealing with a definite integral, so I can write my integral sign. Now I'm going to take my next color. With that next color, I'm going to look for a number over n. So in this case, I have 1 over n sitting out front of here. Now that 1 over n is going to represent my delta x. Remember from our lesson with Riemann sums, this delta x was b minus a over n. So what that tells me is that b minus a over n is equal to 1 over n. Now, this doesn't give me a whole lot of information right now, but it does tell me that b minus a is equal to 1. And remember, a and b represent the limits, so it tells me the difference between those two numbers is 1. Now, what I'm going to do is look for that 1 over n in my function with an I next to it. So I want to try and figure out where 1 over n times I is. Now, if I look at here with a different color, circle that. And I see I have I over n, which is the same thing as 1 over ni. Now that is going to tell me what my x sub I is. Now remember, x sub I is a plus delta x I. So I have I over n. That covers this part. Is anything added to the front? No, there's nothing added in front of here. So that means that my a must be 0. Well, if my a is 0, I can put 0 there. And from my b minus a equaling 1, I know that b has to then be 1. Well, now I'm just about done. What I need to do now is look at my original Riemann sum, and everything that's left is my actual function. So I have a sine and a pi. And so what I'm going to do is actually replace that x sub I. I'm going to replace that with x. So this is actually going to be sine pi x. Sorry, bell rang. dx. Okay? So this gives me sine of pi x dx as my definite integral. Now we can go ahead and evaluate this definite integral using the techniques we've learned in class. All right, so now let's take a look at another one. Similar type of situation. First thing we're going to do, take that first color, circle the limit and the summation. Circle that limit and summation. That tells me I'm going to deal with a definite integral. Now I want to find that number over n. So using another color, I'm going to circle number over n. So if I look here, I see 3 over n. That's my b, my delta x. Again, the only thing that tells me is that b minus a over n is 3 over n, which means b minus a is equal to 3. So the difference between my limits is 3. Now I want to find that 3 over n with an I next to it. So if I look at my function, there it is in there, 3 over n times I right there. That's my x sub I. Well, is anything added to the front of it? So since my xi formula is a plus delta xi, and I don't have anything added to the front, that means a must be 0 again. So in this case, a is 0. We know the difference between b and a is 3, so b must be 3. And now I go back to my function. The only thing that's actually left is e, and remember, I'm going to replace this x of I with x. So my function would be e to the x, and don't forget that dx on the end. Okay, so here's my definite integral that we just rewrote from my Riemann sum. All right, so now let's keep going. Let's do another one. Let's take a look at number 2. Now this one's a little different. This one they didn't write in a summation. What they did is actually expand that summation. So for me, the easiest thing to do is actually rewrite it in a summation. Some of you may not need to do this. Some of you may be able to figure this out right away. But for me, I'm going to go ahead and rewrite it as that summation. Now what I look for here is all the plus signs. That's what the summation means. So I'm going to write a summation. We know this is going to be I equals 1 and this is going to be n. Well, what I'm looking for is some similarities between each of the terms. And then I'm also looking to see what number is changing with each of the terms. And if I look at this, the only number in each of the terms that's changing is the numerator. This is going from 1 to 2 all the way to n. Well, that's what your I is. Your I is starting with 1 and then goes to 2 and then keeps going all the way until you get to n. So our value, or a function that goes in here, is going to be I over n squared. Okay? So now I have this in a summation. Let's bring down this 1 over n. And now we can do exactly what we did in the previous problems. So I'm going to take that color again. I'm going to circle that limit and the summation. That's going to give me my integral sign. I'm looking for that number over n. So that number over n that I see is 1 over n. Okay, so that's going to be my delta x. That tells me that b minus a is going to equal 1. So I know the difference between my limits is 1. Now let's look for that 1 over n times I. Well, 1 over n times I is just I over n. There it is right there. So again, x of I is just I over n. There's nothing being added to the front. So since nothing is being added to the front of that, then a must be 0. So I start with 0. My difference is 1. This must be 1. Look at my Riemann sum. The only thing not circled is my 2 there, my exponent of 2. So if I replace this with x, my function is just going to be x squared. Don't forget that dx. All right, so all of these that we've done, these 3 problems, have all been where a is equal to 0. Okay, these tend to be a little bit easier. Let's take a look at one example where a is not 0. Okay, so now this one difference that they use is k instead of I. You could see both, and it doesn't make a difference, just make sure your variable matches here and here. Start off the same way. Circle the limit and the summation. That gives our integral sign. Next, what we're going to do, find that number over n. There it is, delta x is going to be 5 over n, so that means b minus a is going to equal 5. We have that. Now, look for that 5 over n times, in this case, k, in your problem. And if I look here, there it is. But notice that something is added in front of it. I'm going to circle this whole thing. That's going to tell me x sub I is going to equal 2 plus 5 over n times k. Well, if I look at that, based on my equation for x sub I, which is a plus delta x I, or k in this case, a must be 2. So if a is 2, and we know the difference between b minus a is 5, my upper limit must be 7. So now, based on all this that's circled, the only thing left is the cube. And so I'm going to do the same thing I did as before. This is going to be replaced with x. So x cubed dx. That's one possible answer. The tricky part when a is not 0 is there's actually two possible answers. What we have to assume is that the other case is that maybe a is 0. So in case of a is 0, I'm going to actually get rid of this circle. And instead of circling the 2 plus 5 over n, okay, I'm going to just circle the 5 over n k. And I'm going to pretend that a in this case is 0. So my second case, x sub I is going to equal 5 over n k, where a equals 0. Well, if a equals 0, all right, we can go ahead, sorry for the bell. If a equals 0, then our upper limit at 5 would be 5. Now if you look at everything not circled, we have a 2 plus something cubed. Well, this is going to be our x. So it becomes 2 plus x cubed dx. This definite integral and this definite integral will actually give you the same value. Now this one's probably a little bit easier, all right, but you need to know how to do both. So anytime there is a in front where there's something being added, you're going to have two cases. One where the a is the number that's being added, and the second case is where you assume a is 0. Okay? Using that, hopefully you'll be able to figure out the rest of the problems on the worksheet, and then we'll go over them in class the next day.